Welcome to the section on principles of projection of lines. This is going to be one of the most important lessons in this course. Come on, let's dive in. We'll be using a lot of animations in this lesson to help you visualize the concept of projection of straight lines. Let's start by looking at a straight line in space surrounded by a vertical and horizontal plane, as we did while we learned orthographic projection. What you see on screen is a line AB in the first quadrant that is in front of VP and above HP. As you could see here, the line is in some orientation to the planes. So to start with, let us make the line parallel to both HP and VP. Looking at the line and its relation with the VP and HP, we can arrive at some conclusions or rules. 1. When a line is parallel to a plane, it shows the true length, as you can see here. Since the line is now parallel to both HP and VP, it will show true length in both top view and front view. All relations a line has got with HP will be seen in the VP, as you see here. Similarly, all relation a line has got with VP will be seen in the HP. And I would also like you to recall that the line joining the HP and VP is called as the XY line, which you see here. Okay. Having seen this, let us now change the orientation of the line with HP. Now the line is tilted with respect to the horizontal plane by some angle. Since the line is parallel to the VP, as per what we have learned, the front view will give the true length. The top view will show a shortened length since the line is inclined to it at some angle. One more conclusion we will be able to make here is that when a line is inclined to a single plane, say HP, the view on that plane will be shorter than the true length, and it remains so as long as the inclination remains the same. So you can see this by moving the line so that you can see that the angle remains the same. To explain this further, let us bring the top view close enough to the front view to make this a right angle triangle. The true length, the hypotenuse, top view, the adjacent side, and the line connecting the end B' and B, the opposite side. The length of the top view is actually true length into cos theta, where theta is angle between the line and the horizontal, or the XY line. Cosine of any value will give a shorter value, which is also a proof for the shortening of the top view in this case. So, as long as this inclination or angle remains the same, the length of the adjacent side remains the same. We follow some conventions here while naming points in different views. As per convention, the front view or view on the VP is noted by a single quote along with the letter denoting the endpoint in lowercase. In our case, this will be A' and B'. The top view will be denoted by a plain lowercase. And in our case, it will be A and B. Now let us tilt the line AB with respect to the VP alone. The result will be similar to what we saw before. The only difference is that we see the true length in the top view and foreshortened length in the front view. I think this is the right moment to introduce an important rule or concept. When a line is inclined to one of the planes, that is either VP or HP, the view on that plane or the plane to which it is inclined to will be horizontal line and will be parallel to xy line. I would like to repeat this again. When a line is inclined to one of the planes, that is VP or HP, the view on that plane will be horizontal line, will be a horizontal line and will be parallel to the xy line. Put in a different way, if we find that one of the views is parallel to the xy line and the other is inclined, we can be sure that the inclined view gives the true length. A very important rule that we'll be using in many places throughout our course. The natural continuation to this would be to look at the line inclined to both the planes. We'll do this step by step. First of all, we'll keep the line inclined only to the HP and the front view gives the true length. If now we start tilting the line also to the VP, we see that the front view is no longer the true length. Since we are doing all the tilting with respect to the point A, we will only look at what is happening to the point B. If we watch closely, we can notice an interesting behavior. The point B is moving on a straight line, which we call as a locus of point B in the front view, as we keep tilting the line with respect to the VP. Also, the top view length remains the same. Why? Think for a few seconds. The one-line answer is that as long as the inclination to a plane remains the same, the length of that view will be the same. To be more specific, the top view of point B is shifting its position when the line is tilted to VP. However, the length AB remains the same since the inclination with HP is not changing. So we have covered a lot of concepts so far. So let's try to recap what we have seen so far. Number one, when a line is inclined to only one plane, the view on that plane will be parallel to the XY line. Number two, when a line is inclined to a plane, the length of the view on that plane will remain the same as long as the inclination with the plane doesn't change. Number three, let's see how a line inclined to both the planes behave. When a line is inclined initially to only HP and then tilted to VP, the top view length remains the same as we saw before, and the tilted end of the front view, in our case the point B dash, will move along a straight path. Now, when a line is inclined initially to only VP and then tilted to HP, the front view length remains the same as we saw before, and the tilted end of the top view, the point B, will move along a straight path. So let's stop this section here. So please go back and review this section again and again, so that the concepts will be clear in your mind.